What if boarding a spacecraft to Mars meant saying goodbye to Earth forever? Not as a risk, not as a possibility, as a confirmed scientific certainty. The moment you leave Earth, your body begins a countdown it cannot reverse. Bones dissolving, heart shrinking, brain rewiring itself for a world with no return. Mars gravity is not enough to save you, and Earth gravity will finish you. Your body will have already become something Earth can no longer support. The full story of what Mars does to the human body is on this channel. Watch before they launch, because nobody who goes to Mars is coming home. Every astronaut who boards a spacecraft bound for Mars will face a truth most people never hear. The journey to Mars is not just a mission. It is a permanent departure from everything the human body was built for. The distance between Earth and Mars reaches approximately 55 million kilometers at its closest point. At that distance, even a radio signal traveling at light speed takes more than 20 minutes to arrive. There is no emergency evacuation from Mars. There is no rescue flight. There is no turning back once the journey begins. The total mission duration is estimated at 2 to 3 years, a time frame that changes the human body permanently. If you are enjoying this story, subscribe to Noxar Flux right now. We release powerful space stories like this every single week. For 6 to 9 months each way, the crew floats weightless inside a pressurized cabin, traveling through absolute void. Weightlessness sounds freeing at first. Within weeks, it begins to dismantle the body from the inside out. Astronauts on the International Space Station experience this for 6 months and return to Earth barely able to walk. A Mars mission extends that same physical trauma to a minimum of 2 years, with no recovery period available. Mars gravity is only 38% of Earth's, not enough to preserve the body, not enough to allow a return. The astronaut who steps onto Mars has already left behind the gravitational anchor that kept every cell in their body functional. Scientists have identified 5 major systems in the body that deteriorate beyond recovery during a Mars mission.
Each system fails in sequence. Each failure accelerates the collapse of the next. The process is cumulative and irreversible.
The nearest hospital to a Mars astronaut is 8 months away, traveling at maximum spacecraft speed. These astronauts will be more alone than any human beings who have ever lived. What follows is not science fiction. It is the confirmed scientific reality of what Mars does to the human body. The first and most lethal threat begins the moment the spacecraft leaves Earth's magnetic field behind. On Earth, our magnetic field and atmosphere absorb 99.9% of all incoming cosmic radiation. In open space, astronauts absorb between 870 and 1200 millisieverts of radiation over a 2 to 3 year mission. That radiation exposure equals approximately 632 CT scans delivered continuously over the duration of the mission.
At the cellular level, cosmic radiation breaks apart DNA strands, disrupting the body's ability to repair itself.
Conventional radiation shielding is largely ineffective. Thick metal plating can actually generate secondary radiation. Radiation damages bone marrow directly, weakening the immune system at its deepest manufacturing source. Cognitive damage is measurable and confirmed. Memory problems, slowed processing, and impaired decision-making become permanent. An astronaut experiencing cognitive decline must still pilot spacecraft, manage emergencies, and make life or death decisions.
The eyes develop cataracts prematurely. Vision degradation begins within months and continues throughout the mission.
The cardiovascular system ages by decades under sustained radiation exposure. Arteries harden, blood vessels weaken. Cancer risk increases by 5 to 10%. The body is fighting a war it cannot win and was never designed to survive. Solar particle events can deliver lethal radiation doses in minutes, with no adequate shelter available on a spacecraft. Engineers on Earth can warn of solar events, but the warning arrives over 20 minutes after the signal was sent. Radiation is the invisible first domino. It sets every subsequent collapse in motion before the mission even reaches Mars. Now the skeleton begins its own quiet surrender, a process that starts gently and becomes catastrophic over time. In weightlessness, the body stops defending its own skeleton because gravity is no longer demanding anything from it. Without the daily load of gravity, bones lose 1 to 3% of their density with each passing month. After 6 months, bone loss reaches 18%. After 1 year, it climbs to 36%. A 70-year-old woman with severe osteoporosis has lost roughly 30 to 40% of her bone mass. A Mars astronaut in their 30s could return with the skeletal density of a seriously ill elderly person. The weight-bearing bones of the hips, femurs, and spine are the most devastated, the exact bones needed to stand on Earth.
Calcium from dissolving bones is excreted through the kidneys, dramatically increasing the risk of painful kidney stones.
ISS astronauts train for 2 hours every single day just to slow the deterioration. They cannot stop it entirely. As bones hollow out, the muscles follow the same pattern of quiet and accelerating collapse. Muscle mass disappears at 1 to 3% per month. The legs, back, and core are the first casualties. Muscle fibers shift from endurance-oriented slow fibers to fast fibers that fatigue rapidly and cannot sustain effort. Returning ISS astronauts describe climbing stairs as an ordeal after only 6 months in low Earth orbit. Without regular stress, cartilage thins and hardens, tendons lose their elasticity. Every joint becomes a source of vulnerability. The cruelest irony is that Mars' gravity at 38% of Earth's is not sufficient to halt or reverse the deterioration. Astronauts on Mars will experience just enough gravity to remind the body of what it is losing, but not enough to stop the loss. Every step taken on Mars, under weakened muscle and reduced bone density, is a step toward a point of no return. 6 to 9 months weightless outbound, 18 months on Mars, 6 to 9 months weightless on the return journey. The return flight places a devastated body back into full Earth gravity after years of progressive and compounding deterioration. The risk of fracture from simply attempting to stand would be extreme. Bones that survived space may shatter on arrival.
The heart is also a muscle, and in weightlessness it begins to shrink with the same quiet inevitability as every other muscle.
On Earth, the heart pumps blood upward against gravity constantly. This effort is what keeps the cardiac muscle strong. In weightlessness, fluid migrates upward. Faces become puffy, legs become thin. The body is rearranging itself for a world without gravity. The body interprets the fluid shift as excess and begins excreting water. Blood volume drops by up to 20%. Studies confirm that hearts shrink by up to 20% during extended missions. The pump of life becomes dangerously small. Orthostatic intolerance affects nearly every returning astronaut. Dizziness, fainting, and blood pressure collapse are common. Radiation further damages the cardiovascular system. Arteries calcify. Blood vessels sustain lasting structural damage. The brain absorbs cumulative radiation damage that disrupts the neural pathways responsible for memory and reasoning. Cognitive impairment during a Mars mission is not a hypothesis. It has been measured in animal studies and modeled for humans. Memory consolidation suffers. Decision speed decreases. The ability to think clearly under pressure becomes compromised. Psychological isolation compounds the physical deterioration. No human being has ever experienced this level of separation from Earth. Communication delays of up to 24 minutes round trip make real-time conversations with Earth impossible. By the time a distress call from Mars reaches Earth and a response returns, the emergency is already resolved or fatal. Every system in the body is changing simultaneously. Radiation, bone, muscle, heart, and brain degrading in concert. The compounding effect of all 5 systems failing together is exponentially more dangerous than any single failure in isolation. By the time the mission reaches Mars, the human body has already crossed a threshold from which full recovery is no longer achievable. Scientists are not passive in the face of this reality. Research into countermeasures has been ongoing for decades. Artificial gravity achieved through rotating spacecraft sections is the most promising theoretical solution identified. A spacecraft that rotates slowly enough to generate one Earth gravity would eliminate most of the physical deterioration. No rotating habitat capable of sustaining a crew on a Mars mission has been built or tested at any space agency worldwide. Pharmaceutical interventions targeting bone loss and muscle atrophy are being tested, but none fully replace gravity loading. New shielding materials, including hydrogen-rich polymers, show promise at reducing radiation exposure by meaningful percentages. Despite decades of research, no mission profile currently exists that allows human return from Mars in full health. The first crewed Mars missions will carry people who understand they are not planning a return voyage.
This is not a failure of engineering or ambition. It is the honest boundary of what biology will permit.
The first humans on Mars will be pioneers in the deepest possible sense. They will build something permanent and stay. They will look back at Earth from the surface of another world and know they will not see it again except from afar. Their sacrifice will be enormous. What they plant on Mars will outlast every moment of what they left behind on Earth. Back on Earth, teams of scientists and engineers will support the Mars colony from a distance of hundreds of millions of kilometers. Over time, a colony may grow large enough and self-sufficient enough that the question of return becomes irrelevant. A generation born on Mars will never know Earth gravity. They will be the first true Martians in every biological sense. The universe does not accommodate the human body. Humans must decide how much of themselves they are willing to sacrifice. The people who go to Mars will give up Earth forever. In doing so, they give humanity a future beyond a single fragile world.
That is the brutal and magnificent truth. Mars demands everything and offers something no one has ever had before.
What begins as a one-way mission of necessity may become the foundation of an entirely new branch of human civilization.
The question is no longer whether humans can survive Mars. The question is whether we are willing to pay the price of becoming something new. Subscribe to Noxar Flux so you never miss a story. New space documentaries are coming every single week, only on this channel.